previously, we talked about how to graph a linear equation. So in these questions, we are given a equation. For example, y equals negative 3x plus 4. And we were supposed to graph it in the xy plane or xy coordinate system. So what we did was we picked some numbers for x and solve for y, and then we get points and we join the points to get the line. But in this video, we're going to do the opposite. So we will get some information about the line. So you will know what the line looks like in this picture. What we are not given is this equation. So this will become the unknown. So this will be given. We know some information about the line. And we supposed to find the equation that looks like this, y equals negative 3x plus 4. But of course, these numbers could be different. So how do we do that? And we also talked about Provin's concept, slope. And notice that the slope formula, if we have 2 points, and we can use the formula rise over run to find the slope. And also the slope tells us how steep the line is. So if they tell us the slope is 3%, you will be able to draw the line. But in this video, we're going to look at the opposite type of question. So for example, here we have a question, find the equation. So the equation becomes the unknowns. That's the question of the line. So the line will be given. We know some information. For example, we know the slope is 1/2, and also we know this line goes through this point 1 and 2. And with the pieces of information given, so this is given, the slope is given, and also a point is given. But this is the unknown. We're trying to solve for the equation. And with the information given, for example, the line goes through the point 1, 2. So I'm going to, on the xy coordinate plane, I'm going to find the point 1, 2. So x equals 1, y equals 2. So it's going to be a point here. Also, we know the slope is 1/2, and we know the line is going to look like this. Okay, so when we are given the slope, we know how steep the line is, and we also know the line goes through this point. We are going to be the line is going to be determined, or we are able to draw the graph of the line. So now we have the graph, but we need to find the equation. So what is the algebraic equation for this line? And what we're going to do is I put the slope formula here because we're going to have a few formulas. So here we're going to talk about 2 formulas to help us to solve for the line. The first formula comes from the slope formula. So again, this point is 1, 2. And we know a line, when we solve for the equation of a line, we know a line consists of infinitely many points. So any point on the line, we have infinite many solutions and infinite many points on the line. I was just drawing a few of them, but that's not all. That's just some of them. But any of these will be a solution of the algebraic equation we're going to find. Just like the first problem we talked about in a previous video, we're given equation and we plug in numbers, given pairs to determine which one is the solution. So the same thing here. We don't know any of these pairs. We don't know the equation, but we know any of the point corresponds to a ordered pair with the x coordinate x, let's just call it x, and y coordinate, let's call it y. And so any of these points can be represented by an ordered pair of numbers x and y. And notice that we got 2 points. One of the points is given by the problem, 1 and 2. So this is a given point. And there is an unknown point. And this is the point we actually don't know we need to solve for, because once we know the relationship between x and y, we know the equation. But what we're going to use is, even though it's an unknown point and we have a known point, and we can use the slope formula, we can plug them into the slope formula, because the slope formula only needs 2 points. So we need a point 1 and x1, y1, point 2, x2, y2. So as long as we have 2 points, we can plug into the formula and get the slope. So this is what we're going to do. We write down the formula, and we can plug in the numbers here. So what we can do is I'm going to rewrite the formula here. M equals y2 minus y1 over x2 minus x1. So what I can do is I am going to again, m here represents the slope. So I can replace m with 1/2 because it's given. The slope is given. Previously, we are given all the numbers, and the numbers for x1, y1, x2, y2. We just need to plug them in there, as you can see in this example here. I'm going to show you. Click here. In these two examples. So we were given all these x1, y1, x2, y2. We plug into the formula, so we were able to find the slope m, which is a number. But in this case, we are given the slope, the number 1/2. And we also know one of the order pairs. So here we know x1 and y1. So x1, this is, let's say, call this x1, and this is y1. So x1 is 1. I'm going to replace this x1 with 1. y1 is 2. So now what we have is, if I rewrite this to make it look a little better, so you have y2 minus 2, x2 minus 1. And notice this is an equation and also has xy in there. And actually, I should also go ahead and plug in the other point. And notice that we have 2 points. So that's called this one x1 and this one y1. And this is x2, y2. But this x2 and y2, we could just use a general letter. We can get rid of subscripts. I mean, if you want to keep them as, if you want to use x2, y2, you will end up with this. Since we don't have another pair x1, y1, we don't really have to distinguish them from anything else. We could just get rid of the subscripts. Just use the x and y. So the only time we use x1, y1, x2, y2, when we have 2 pairs, we have to distinguish them. So now, since in this equation, after we plug in 1 and 2, we don't have x1, y1 anymore. So it's not necessary to still have keep the subscripts y2 and x2 there. And when we look at this equation, that's exactly what we need. But it kind of looks different from what we have previously. Like, for example, we had y equals negative 3x plus 4. And that's because it's in the fractional format. So we can do some algebraic work to turn this into something like that. So for example, what we can do is we can multiply both sides by x minus 1. And since I want to get rid of the denominator, so if I multiply the left-hand side by x minus 1 and the right-hand side by x minus 1, because x minus 1 cancels x minus 1, because if they're the same thing, we can cross them out. And now we end up with 1/2, bring down, times x minus 1, bring down, and the right-hand side, they're canceled, so we're left with y minus 2. And this looks closer to the equation we've seen before. If you want to get y by itself, you can do one more step by adding 2. So I'm going to do that on the next page. So right now, I am just going to stop here at this equation. Okay, so what I did is you plugged in those numbers. For example, the slope is 1/2, and one of the points x1, y1 is 1 to 2. So I plugged them in there. If I don't plug in those numbers, in general case, so if you look at what we just did, so we just multiply, we got rid of the denominator because we don't want the fractional format. So we can multiply both sides by this denominator, x2 minus x1, just like we had x minus 1 here. So after we multiply both sides by x2 minus x1, they cancel out. The top cancels the bottom, because this you can put it under one underneath, so they cancel each other. So now we end up with something like this. And what I did is I moved the m and switched the m and that, because it looks a little easier, just a single number m in front of the parentheses, so we can distribute easily. And the right hand side, since they are canceled out, so we only left with y2 minus y1. So again, this equation is the same as the slope formula. The only difference is we got rid of the fractions by multiplying the LCD, the denominator, x2 minus x1. And the other thing I did here is I switched the left hand side and right hand side. So I put the right hand side, I moved the right hand side to the left and this to the right. And when we switch both sides together, it's still going to be the same. And just like if I have x equals 2, it's going to be the same as 2 equals x. So I switched both sides together. And the reason we do that is because usually we like to write y's, put y's on the left and x's on the right side. If you don't want to switch them, that is fine. Okay, so now this equation we got right here is called we call this equation right here the slope, point slope form. So this formula is the first formula we're gonna need to remember. Is called point slope form. So with the formula, it's to go back to the example, it's gonna be much easier now. So all I have to do is I plug all the numbers into this formula. So for example, y2, I'm just keep y2, and y1 is 2. I replace y1 with 2 equals m is the slope, which is 1/2. So I replace m with 1/2. And x2, I don't have x2, but I do have a number for x1, which is 1. So after I plug everything into this formula, and I will get the answer immediately, which is the same as what I got previously by plugging numbers into the slope formula directly. But now, since we don't like the fractional format, so we're not going to use the slope formula directly, or we're going to use this formula without the equation, the fractions. So again, where did this formula come from? It comes from the slope formula. We just moved the denominator and to the left hand side. And again, the other thing we can do is, since after we plug in 1 and 2 for x1 and y1, and notice that x2 and y2, there are only x and y's left. We don't really have to distinguish them from anything else. So that's why I could just get rid of the subscripts, just replace them with the y and x. So in general, the formula we're going to be given is we're not going to need x2 and y2. So we're just going to have the formula y minus y1 equals m times x minus x1. So this is our first formula that we need to remember. I will rewrite it here, y minus y1. Again, I got rid of the subscripts and 2. So that's point slope form.